Uh-oh, better pause that recording real quick.
I got to downstairs with one of those like megaphone thingies. It was like 20. I have to be at like 7. You know what that was? It was waking me up. And I was like, what are you doing?
Mm-hmm.
I could have gotten an extra 40 minutes of sleep. But no.
I have today 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 19 examples. So, but this isn't one of those situations where every example takes, like 5 minutes. So if you're a ninth grader, I feel like you probably learned some properties of exponents last year in 8th grade. If you're an 8th grader, which I don't think I have any 8th graders in this class. So you guys all should have come here from Mr. Manlove's 8th grade class. That's, I think, correct. So let's go through all the properties. These problems are going to get more and more difficult as we go. You shouldn't struggle for like the first 7 or 8 minutes. If you do, just let me know, okay? All right, so our next unit, like I said, is going to deal with exponents and root signs. You guys have seen those square root signs. Generally speaking, they're called radicals because not all roots are called square roots. There are cube roots and fourth roots and other types of roots. So those are generally just referred to as radicals. So we won't talk about radicals today or probably tomorrow or maybe even the next day. I don't know, but it's all going to be exponents, properties of exponents here for at least a couple of days. So let's get right to it. Rather than address the properties by their names, I can as I go if you would like. I think it's better just to learn them through examples. And then maybe at some point, like later today or tomorrow, I can take the properties and once you've worked with them and have gained some familiarity with them, then I can put them in like a box for you and say, hey, copy this down, like boom, boom, boom. There's like 5 properties or something that you need to know. But you'll know how to use them all by the time we're done here today. So let's get to it. So the first property of exponents deals with math problems like this. And there's always going to be one of 2 answers that someone would give for this. There's, honestly, it's not illogical if you say the wrong one because it's got some basis behind it. But do you guys happen to know what this equals? Yeah, I mean, you're either going to say, unless something weird going on that I don't know about, you're either going to say x to the 12th or x to the 7th, right? There's no other logical answer. The answer is x to the 7th. And it's weird because I feel like what are you doing? Like that's a multiplication sign. Well, just kind of always remember that this property functions because of this. What does x to the 4th even mean? It means x times itself 4 times. It's important that we not say that it's x times 4. It's certainly not that. It's x times x times x times x. And what is x to the 3rd? X times himself 3 times. And I don't know that you could really sit there now and say, boy, I still don't see why that's x to the 7th. Like it's right in front of you, right? If you stack 4 x's side by side and 3 x's side by side, pretty hard to refute the fact that there are 7 of them, hence the answer. So make sure you are aware that when you have something like this, and it is multiplied by another something like that, note that the bases x are the same, that you add. Even though it's a multiplication problem, you add the exponents together. Okay. All right, let's put a little bit more meat on the bone this time. Let's do 3y to the 5th times 2y to the 6th. Anyone want to take a shot? It definitely involves the number 6. Good. And a lot of times people will say 5 because they say, wait, hold on, I thought you just told me that I should add. And, don't lose sight of what you've known since like seriously 3rd or 4th grade. And that is that 3 times 2 is still 6, right? Those are not exponents, so we're not using a property of exponents there. I'm just going to take this normal 3 times this normal 2. They're not exponents or anything weird like that. 3 times 2 has always been 6. Now, for this other part of it, we do have to use the property that we just learned. These other numbers are exponents. Y to the 5th power and y to the 6th power. That's when we add the 5 and the 6, and we get y to the 11th power. So that's how you would attack a couple of problems like that. All right. So that basically covers the first property of exponents, and I'm sure there's a name for it. I don't know what it's called, but let's not put it in its formal, like, confusing form. Just understand when to add the exponents together. Any questions on that one? Okay. On a related note, we also have problems like this. X to the 12th divided by x to the 4th. And again, I just cannot for the life of me see any reason for anyone to get anything other than 2 logical answers. What's one of them? X to the 3rd seems logical, right? But it's very much not right. Right? And there's nothing wrong. Like, having taught this lesson 100 times, I am always happy if someone says that, because it makes sense. 12 divided by 4 is 3. What should this actually be? It is x to the 8th. Indeed, it is. In the same way that we added exponents when they're multiplied side by side, here we actually subtract them. And again, I will do my civic duty here and show you why this is. You could never argue that you don't buy it ever again after sitting through this example. So here it goes. X to the 12th looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that we agree is x to the 12th, right? And then on the bottom, x to the 4th looks like this. And you know from the old days that when you reduce fractions of any sort, all you're ever looking for is things from the top and the bottom that are the same, right? And I see it with my own eyes that there's this x can cancel this x. This one can cancel this. This one can cancel this one. And this one can cancel this one. And of course, I wouldn't ask you. You see that there are 8 of them left, correct? So it just proves the point, drives the point home that even though it's a division problem, we subtract exponents. We do not actually divide them. Got it? All right. Now, you know that we subtract them, correct? Okay. So prove to me that you understand that with this example. M to the 8th divided by m to the negative 2. You will see lots and lots of negative exponents over the next week or 2. So be prepared for that. Now that you kind of know what I'm up to, there again, I would say are 2 logical answers for this. M to the 6th is perfectly wrong. And it's wrong, but it's a beautiful first shot. It's a great first step in there to say, it makes sense to me, 8 minus 2 is 6. Braxton? It is m to the 10th. And if you really embrace the rule that we just kind of sort of absorbed with that last example, we said it ourselves. We subtract, right? Well, here we go. 8 minus negative 2. 8 minus a negative. What happens when a minus and a negative touch butts? They become a plus. And 8 plus 2 is 10. Good job. So that essentially is 2 rules down, several to go. So far what we've learned is that if the things are side by side multiplied, we add their exponents. If they're above, below division, we subtract their exponents. Okay. On then to the third property, and it looks like this. I mean, I don't know about you, but if I can't remember back this far because I'm getting old, but if I were sitting, listening or watching or being a part of this lecture, I'd really want to say something like maybe m to the 12th, right? Or it could be m to the 64th, right? Because 4 to the third is 4 times 4 times 4. Would anyone want to say m to the 7th? Maybe. What do you think it is? It is this. And again, I feel like it's my duty to show you once and for all that this isn't a bunch of like hullabaloo black magic going on here, right? Please don't be distracted by what's going on in the hall. Okay, focus in here, okay? Here it is. What does it mean to raise something to the third power? Say it. Exactly like that. It means to multiply it by itself 3 times. So, Your Honor, here it goes, Exhibit A. Here comes m to the 4th. But I need to multiply 3 copies of himself. Here's another m to the 4th. And here's another m to the 4th. Does anyone have any issues with that being m to the 4th to the 3rd? Now go back to the first rule we learned today. What do you do when things are stacked side by side with their exponents? You add them. 4 plus 4 plus 4 is 12. Now, there's a much shorter way, of course, to do that. And instead of showing it like that, couldn't I have just taken 4 times 3? Yes, correct. Okay, let's go again. This introduces another property of exponents, okay? So I kind of just jumped right past that one and jumped right into the next one. So this will be, when we go back and kind of encapsulate this or put it in a box, this will be property 4. Again, feel free, you know what I'm all about, making a mess, right? You got to make a mess to get good at math. So make a mess. What do you think the answer to this might be, Morgan? Did you say 4x to the power of 20? Nope. Yeah. There's a distribution property for exponents. We're not allowed to call it that. Gunnar already said it. You just can't hear him because he whispers answers at me, but it is 16x to the 20th. What happens is exponents that are on the outside of parentheses actually can get distributed in, provided that everything inside is not attached by plus or minus. Plus and minus is more going to be in a month or so when we get to that. So for now, I look at it like this and I say, okay, inside the parentheses, we got Mr. Purple. And inside parentheses, we got Mr. Red. And this exponent of 2 is going to say, I'm going to become the exponent of Mr. Purple and Mr. Red. Since there's 2 of you, I will do 2 things. So when the 2 becomes the exponent of that 4, what is 4 squared? It always has been. 4 times 4 is 16. And then take the red guy, and what is x to the 10th squared? X to the 20th. That's when we multiply the exponents together. Got it? All right, let's do that same kind of problem again, but I'm going to buff it just a tiny bit. So we're going to do 3x to the 2nd, y to the 8th, all to the power of 4. Thank you, Jesse. How many things do you see inside the parentheses this time? How many entities are there inside the parentheses? There are 3. And it's very important, whether you use colored pens or not, that you identify them all separately and say, you, Mr. Purple, are your own creature. You are not part of the X. And you, Mr. Red, are your own creature. And you, Mr. Green, are your own creature. There are 3 things. They will each get smacked by that exponent on the outside. So let's begin. What is 3 to the power of 4? It's not 12. Don't worry, you're going to get really good at these. Here's a trick for you. If I have 3 to the power of 4, you would agree that I could break it into 3 to the power of 2 and 3 to the power of 2, right? Because 2 and 2 make 4. What's 3 to the 2? 9. What's 3 to the 2? What's 9 times 9? So 3 to the 4th, by definition, must be 81. That will become one of those multiplication facts that you just learn because it'll just happen organically. You'll have no choice. Now let's go to the second distribution. What is the red guy? X to the second to the fourth. X to the eighth. Very good. And then the last is the green guy. What is y to the eighth to the fourth? Y to the 32nd. Very good. So far, so good. Okay. Now, before we transition into zero and negative exponents, I'm going to do one more example just to make sure you understand one really important concept. So we're going to open a set of parentheses, and we have 2 x to the third, y to the negative fourth, times 4, x to the negative first, y to the 10th, and we're going to raise it all to the power of 2. You guys know the order of operations, right? And you know that the first thing in the order of operations is always to do any math that you can inside of a set of parentheses. So there are some who would look at this and say, my gosh, there are 6 things inside the parentheses, and I need to distribute that outside exponent to all 6. And then there are those that say, no, I can put some stuff together on the inside, right? Let's follow the order of operations and let's clean up this train wreck, this mess. So forgetting everything on the board that is in red, let's forget everything that's in red, ignore it, and let's just do the math inside the parentheses. What will we get? What is 2 times 4? Now do your x's. How many x's will you get? X to the 2. And we get that because we're adding the exponents together. And how many y's will we get? There's a y right here. And there's a y right here. Add those exponents together. What do you get? You get 6. And now I'm going to reclose the parentheses and rewrite my exponent. And now I'm like, okay, this feels better because now the exponent only has to distribute to 3 things. So here we go. When the exponent goes to the 2, what's 8 to the power of 2? Yes, 64. What is x squared to the power of 2? X to the 4th. And what is y to the 6th to the power of 2? I can tell this is going to be the property that you struggle the most with. I haven't heard but one person say it. It is y to the 12th power. Remember that when you have an exponent that already exists and you raise it to another exponent, that one someday we're going to call the power to a power property. Exponent raised up again is where you multiply the exponents together. Got it? That for me sort of marks about the halfway point of your learning. Are you good so far? Right. And don't worry, the idea is when I give you this assignment, you're going to get lots of practice. So, and there'll be probably multiple assignments just like this. So you'll get lots of opportunities to get better at this. All right, here we go. Next property. The heck? What the heck is x raised to the power of 0? It's not x to the 1. Nope. It's 1. Sorry. How about this one? How about y? This has got to be different, right? Y raised to the power of 0. It's 1. How about this one? Negative 10. Oh, watch out. This one's going to be really tricky. Negative 10 raised to the power of 0. You're on to me. We can summarize this rule in our notes as follows. Anything. When you raise it to the power of 0, guess what you get? 1. You get 1. fact, it's always fun to see who's listening come quiz day. Mark my words, this will be one of your quiz questions or very similar. I'm going to do something hilarious and fun like -64, x to the -13th, y squared, z to the -54th, all raised to the power of 0. And it's always fun to see who's listening because guess what it is? It's 1. Got it? So to summarize that property, anything to the power of 0 equals 1. And I will quickly show you a little bit of explanation as to why that is. Because if you're a math person, you might be in your mind going, I don't buy it. I don't buy it. Check it out. You can do this with any number, by the way. If you're doing your homework later, maybe in like your dad says, can you show show me how that works? You could pick a different number than what I'm about to do, but here it goes. Let's do like 2 to the power of 5, 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. This works for any number. Does anyone by chance know what 2 to the 5th power is? Oh, if I wanted that, I would have said 2 times 5. 10. Nope, that's 5 to the 2nd power. You can count them on your fingers. Ready? 2 to the 5th power. 2 times 2 times 2 times 2. 16 times 2. So 2 to the 5th power is 32. Now let's work our way down. I want you to see, and hopefully you have a moment here where you're going to go, ooh, that's neat. What's 2 to the 4th power? Of course it is, right? We already got there. What's 2 to the 3rd? What's 2 to the 2nd? Take a look at what's happening on the right-hand side of the table. What's 2 to the 1st? This is just one way. It doesn't prove it. It just gives you something to hold on to. And you say, why is this? Well, it's really cool. Look at it. Divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. What's 2 divided by 2? Jackpot. And that works for any base. If your mom wants to see an example of it later, you can say, look, mom, you could bust out 3 to the 5th, 3 to the 4th, and show her like, hey, it's always worked. So that's about the best I can do. If you ask me, why is anything to the 0 power 1? That's going to be my go-to explanation right there. And the last property of exponents, and then we put it all together, is this one. And if you think the answer is -16, you are completely wrong. And it's okay. But in Algebra 2, if you pull that, you're going to owe me money every time you make that mistake. So the answer is not -16. You ready for this? Ready? Ready? It's that. What is this? Witchcraft. Watch this one. You ready? How about x to the -10th? What do you think that is?
1 over 10.
It's not 1 over 10. It's 1 over x to the 10th.
Okay.
Are you on to me yet? How about 2 to the -3rd?
1 over
2 to the 3rd? 8?
Oh.
You want to go again?
Yeah.
Come on, let's go again. Come on, you little chickens.
I gotta go. I'm catching it.
Yes. The moral of the story is this, that when something has a negative exponent, it does not turn the answer negative. It just flips it. Now, you ready to have your mind really blown? Watch out for this one. Okay, now I'm really going to mess with you. 1 over x to the negative fourth is x to the fourth. 1 over 6 to the negative second is 36. So hold on a second. So hold on. So you just finally get your head around the fact that, hang on, Mr. Ahern, hold on. So if something has a negative exponent, I move it to the bottom, right? Look, negative exponent, move it to the bottom. 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 Negative exponent, move to the, and then I go and I show you that, well, what if it's already on the bottom and it has a negative exponent? Where do I move it? To the top. Negative exponent to the top. The negative exponent property is actually, once you get over that initial hurdle, it's actually really stupid easy. All it says is if something has a negative exponent, if it's in the top, move it to the bottom. If it's already in the bottom, move it back to the top. Done.
Now what happens if the exponent is positive? And that happens on.
Of course, then we would just leave it alone. So like if I had like 1 over 6 to the second, then that 6 to the second's like, dude, my exponent's positive, don't move me. So this one, good question, Braxton, would just be 1 over 36. We only physically move things up and down if the exponent is negative and tells us to do that. If it's positive, leave it alone. Okay. How about this one? I'll take your answers. I know we're getting to the point where it's hard to keep listening, but just for your planning, this is probably going to take all hour. So give yourself a quick smack across the face or something to stay alert because we're not done. We're not even close. So sorry. Nope. First off, again, I would like to repeat what I said earlier. Negative exponents do not turn things negative. They have no control over that. What do negative exponents do? They don't make them positive or negative. What do? They change if they go on the bottom or the top. Preach on, Brother Belial. Preach on. That's all negative exponents have the power to do. Here's the answer. Now, let's talk about why that is. Does the 3 have a negative exponent? No. The 3 is like, leave me out of this. I'm just sitting over here. Like, don't mind the weird guy next to me. However, it's the X that says, yeah, I'm the guilty party. I've got an exponent of -2. So what we did is we physically left the 3 where he was on top. You see how when I say top, do you guys understand that all of that is currently over 1, right? Like the number 4 is on top, 4 over 1, right? So like the 3 says, I'm going to stay here. And the X says, I'm peacing out. And he moves to the bottom. Okay, let's try that again. How many entities do you see? I see 3. Their names are 10, X to the something, and Y to the something. You must treat them each independent of one another. Does the 10 stay or go? 10 stays. Does the X stay or go? So I need to turn this into a fraction. And when he goes, his exponent moves to positive. And does the Y stay or go? The Y stays because his exponent is perfectly good. Look at that. Exponent of +3 is like, leave me be. So we only move things if their exponents are negative. Got it? And one more, and then I'm going to, well, 2 more actually, and then I'm going to flip the note card over, and that's that. Any answers? I love it when you guys give answers, even when they're wrong. You know that I just I just love it. Fine with it. Yeah. No, we're still kind of in the same area. By the way, you now know all the properties. Okay. There are no more properties. Now what's going to happen is the problems are going to start putting lots of properties together. But you know them all. They both have to go to the power of -2 first off. Let's go ahead and address this. So let's take this exponent on the outside. And you should always want to distribute, by the way. So I'm going to take this and give it to that. And I'm going to call him 3 to the power of -2. And then for the follow the green arrow, that's going to become m to the power of -2. Who stays and who goes? They both go. Yeah. Basically, they're both like, oh crap, now we both got stuck with a negative exponent. Great. And so if the 3 packs up shop and heads south, and the m packs up shop and heads south, what's left on top? Just the number 1, right? You guys know that ones show up to just hold things together sometimes. We call that a placeholder. And then what's on bottom? 3 to the second power. Just like that. I might conclude the lecture after this example, and what I'll do maybe, because I know you're getting to the point where it's like, I can't keep doing this because the back page is, it takes no prisoners. So maybe what we'll do is one more example, and I'll hand out the homework, and we'll see if you can get like the first 8 or 10 problems done. That would be better. That would be better for your sanity, I think. And then we'll start tomorrow with those 4. Okay, good. One more. What should we do first? Yeah, and we are going to say that word. I'm telling you, in any book I've ever looked at, no one calls it the distributive property of exponents. And I guess I understand because there comes a point where if there's any plus or minus in these parentheses and you try to distribute the exponent, you're never going to pass another math class again. So like I understand the logic, but we just can casually say, let's distribute. It's all good. So let's distribute that power of -3 and let's give it to everybody inside. So inside we have a 2 that says, I will receive your exponent of -3, and I will look like this. I would recommend just doing one thing at a time for now, okay? And then there's an x that says, I also will receive your exponent. What will x's new exponent be? +12. Very good. Remember, that's when we multiply the exponents together. And then follow the purple arrow. Y says, I'll take that exponent too. Give me some of that. What is y's exponent now? -9. So when something already has an exponent and you distribute a new higher exponent onto it, they do not actually exponentiate. Like you're not putting 27 or 64 on those. Those are just multiplication problems. 3 times -3 is -9. Now is where we go through the checklist and say, who stays and who goes? Who stays? Only the x. This is the only one. I'll put a box around him that can say, I have a positive exponent, leave me alone. So x to the 12th says, I will stay on top and I will hold this fort together. But what happens to this guy? He drops to the bottom, doesn't he? He becomes 2 to the 3rd. The base never changes. The 2 doesn't change. It's just the exponent that changes positive, negative as we move things around. And then also, of course, what happens to this joker? He moves to the bottom as well. And if you were to turn in an answer like this, I'd almost give you credit for it. But what's the one other thing I didn't do? No. You guys have heard this word before. You've seen it on every math assignment. Do you guys know what simplify means? It doesn't mean reduce. I guess here's the way I try to explain this because I know that this word is like ubiquitous and kids are like, what does that mean? It means keep doing math until there's no more math to do. You understand that? And do you see some math that we could do? I do. What is it? What is 2 to the third? It is 8. So the final answer to this problem would be x to the 12th over 8y to the 9th. Now that is a simplified answer. Why can I not simplify those two green things? Because they don't have the same base. One of them's x to the something, and one of them's y to the something. I can put those together. No, can't do that. So I'm going to cut it off here, and I'm going to hand out the assignment, and let's set a goal to see if we can maybe get through 8. Let's see if we can get through 1 through 8. That's the goal, okay? Problem 1 says 3 b to the 4th times 3 u to the negative third b squared. Remember, when we talk exponents, an exponent of 2, you can say squared. Exponent of 3, you can say cubed. You don't have to. But after that, we don't use other words. It's to the 4th, to the 5th, to the 6th. So if you were to like go on Wikipedia, you might be able to find fancier words for like the 4th power and stuff. But I don't even know what they would be. So you don't have to say squared and cubed. You can always say to the 2nd, to the 3rd. It's up to you. How many entities do you see? I see 5. If you still don't know what I mean by that, there's a 3, a V, a 3, a U, and a V. Are we clear? So let's always begin with the numbers that are not algebraic. They're just numbers. What is 3 times 3? Therefore, our answer will contain the number. Because 3 times 3 is 9. That's not a property of exponents. You learned that long before you met me. Don't worry about that yet. Just the 3 times 3 is 9. Are we clear? Now, what I like to do, since this is your first day learning this and I can give you habits, is I like to go alphabetically. Most math people will tell you the same thing. In the English alphabet, U comes before V, right? So look around the problem. I see U to the negative third. Does he have anyone else to go with? Therefore, he becomes part of my answer. And I know if you're thinking like, whoa, hold on. I get it. We're going to fix it in a little bit. But I do see this. I say V. Look, you have a homie over here. Bring them together. What do you get? B to the 6th. Remember, if it's V to the 4th to the 2nd, that's V to the 8th. But V to the 4th separated, multiplied by V to the 2nd, that's V to the 6th. That's what we get. So now you look at your answer and you ask yourself, how many entities do you see? And I see 3. Does the 9 stay or go? 9 stays. Does the U stay or go? Goes. And he becomes U to the 3rd. Does the V stay or go? And there, my friends, is problem 1. Now I ask, please, that you get the next 7 done without my assistance. This is all going to be a whole lot easier than you think. Mark my words. Okay, practice, practice, practice. So while I still have the recording going, again, my expectation is that between now and like 23 hours and 15 minutes from now, I want you to have problems 1 through 8 done. And then tomorrow I'll start class with a lecture that will help you with the rest of the page. Got it? Okay, cool.